Okay, let me start out by answering the ones from yesterday. Thought I'd enter the screen from the other side this time. But let me answer those first, and then just a new thing to it. Keep adding on as far as solving. But let's do these first. Okay, so number one was x plus 12 equals 15. Okay, so the one step that you have to do is move the 12 and make sure you move it over there as well. So you got x is 3. Okay, so that was a warm-up one, kind of remember. Okay, x plus 7 equals 29. Same thing, need to move the 7. So you get 22. Okay. And then we moved the variable to the other side, but it's the same thing. Okay, so instead of having the variable first, we just flip places, but you still need to move this 8. You still need to isolate the y, and it's a positive 8, so you're still going to subtract 8, and you get y is 28. Okay, so whether it's which one's first, that's how you move it if you're at addition there. Another one of those that I put was number 4. Okay, 9 plus y equals negative 13. So you're going to move the 9 the same way by subtracting it. Now the difference on this one is it was already negative 13. You're subtracting another 9. So now you're at negative 22. So be careful with your negatives there, because you're at negative 13. You're subtracting another 9. And so you get negative 22. If you had positive 13 minus 9, that would be 4. But you don't. You have negative 13. So don't forget your negative rules. Okay, then we got some subtraction ones. So we got x minus 3 equals 10. So instead of subtracting the 3, you're going to add the 3 to make it 0. And that gives you 13. Okay, same thing with this one. X minus 7 equals negative 3. So add 7, and you're going to get, now this is negative 3 plus 7, which is 4. Okay, and always, you can always plug them back in and check, 4 minus 7 is negative 3, or 13 minus 3 is 10. You can plug them back in and make sure that you're doing them correctly. Okay, let's keep going. We had a couple more. I think we changed place. Well, not yet. Number 7 was, I just made this one bigger. Y minus 52 equals 13. So you add 52 again, okay, and y is going to equal 65, okay. And then number 8 was 10 minus x. This is the one that switched places. So you're going to have a negative variable when you're done, because you're going to subtract 10, and you get 5, okay. And this is the one I was talking about, that if you move the negative over here, it's now x equals negative 5. I'm going to come back to that one here in a second. Let's do this one. I did have a couple questions on this one, and I didn't do one, I apologize, but it's the same principle. If I move 12, okay, move 12, I get negative y is negative 15. Okay, that's where we're at this spot. Now, if you drop the negative off this one, like we did here, we dropped the negative. We actually didn't, we just dropped it, but we did move it. Okay, so we moved it over here. So where this was a positive, it now became negative. Well, if you're doing that here, if you're dropping it, or however you want to say it, we're gonna talk about what we're actually doing today. But if you're taking it off or moving it, then you got to change this one as well, or drop it from this one as well. So it's y is 15. Okay. So that was a positive 15. And if you missed that one, that's fine. I didn't apologize. Like I said, I didn't do one where they were both negative, but I was showing where if you change this sign, then you need to change this sign. So same thing, if you change this sign, then you need to change this sign. Now what you're doing there, so I'm gonna highlight, because it leads us into kind of what our next section is, but what you're actually doing here to get this is you are dividing both sides by a negative number, by a negative 1. Because when you divide this by negative 1, remember there's a negative 1 here, okay? We don't see the 1, but it is there. So if you divide by negative 1, it gets rid of it, and you divide by negative 1, that's what gives you negative 5 here, okay? So that's what we're going to be doing next. is multiplication and division. So I want to show that there is a reason for that, but I think it's just as easier to remember that if you move the sign from here, you just move it over here. Or in that other one, if you had this, or I think it was a Y, if you are dropping the sign from here, then you're dropping the sign from there. Okay, so whatever is the easiest way to remember that is how I would do it. Okay, now what I was talking about as far as moving into multiplication division, I'm going to start with let's do this as a multiplication. Okay, now I want to point out the difference. This is not 3 plus x equals 9. Okay, that one we subtracted 3 and we got 6. Okay, this is not 3 plus x. When you write numbers together like that, numbers and letters, that means multiplication. Okay, so if I was to put a 6 there, that's going to be 3 times 6, which is 18, which is not 9. Okay, so this is not 3 plus x. Okay, but you will see problems like this where it says 3x equals 9. What do you do then to solve this? Now we may have already in our mind, like I said, these are pretty simple, already know that this needs to be a 3 because 3 times 3 is what gives me 9. But how do we, when they get bigger or harder, how do we go to solve that? Well, let me start with, we are still isolating the variable. That's still our goal. Okay, we still want to get the letter by itself. Okay, it's just like when we were adding or subtracting, we want to get that letter by itself. The only difference is when you're multiplying and dividing, like when it's a multiplication and division problem, you don't want to subtract 3x, because if I subtract 3x, what happens? Everything disappears. 3x minus 3x is 0. If you have three x's in your hand, let's say you're holding an x and x and x, you're holding these x's, and you take those 3 x's away, you're left with nothing. Okay, not even the variable. And so you don't want to just subtract 3x. You can't do that. Another thing you can't do is subtract 3, because these are not like terms. You can't subtract a number from this has a letter. So I can't separate those two that way. So I can't just subtract 3 and have this be 0. Besides, we don't want this to be 0x, because 0 times anything is 0. So once again, we've lost everything. We've lost our variable and our letter. So we're not going to subtract 3 in this spot. We need to actually make this, right? Our goal is to make this x, right? We want to isolate the variable. We want it to just be x. Well, what is x? Okay, it's 1x. Remember, we don't write the 1x, but it's there. It's a 1x. So to get this to be 1, not 0, but to get it to be 1, we need to divide it by itself, right? If I divide 3 by 3, I get 1, which is 1x, which is what I want. Okay, so when it's a multiplication problem like this, we're going to divide by the same number. Now, you're starting to go, oh my goodness, how do I keep all these straight? I always remember opposites. Like when I had it as, let's say x plus 3 equals 9. Okay, instead of adding, the opposite is subtracting. When I subtracted, x minus 4 equals 12. Instead of subtracting, I did the opposite. I added. So I kind of keep that mentality. Instead of multiplying, the opposite of multiplying is division. Okay, so that's how I kind of keep track of which ones I'm doing. You could, however you need to think about it, maybe making it a 1x or dividing, that's what you're doing. So once I divide this side by 3, I get this to be 1x, which we don't need the 1. But remember, now our rule still applies. If I divide by 3 over here, I have to divide by 3 over here. And that's what's going to give me my 3. Remember the original problem, we had figured out that I need to multiply this by 3 to get 9. So that's how you solve it. Okay? Let's do another one of that. Let's mix in a negative here. Negative 4x equals 12. Okay? Now, in our brains, we know we need to multiply negative 4 times a negative 3 to give me a positive 12. So we need to come out to negative 3. Well, let's see if our process works. Okay, instead of multiplying by negative 4, I'm going to divide by negative 4. Okay, those cancel out then, and this is going to give me negative 3. That's what we needed. Okay, let's do another one. Negative 3x equals negative 9. Okay, we know we need to multiply it by a 3. That's going to be our answer. See, these are easy, so we can maybe think ahead, but let's try our process. Instead of multiplying by negative 3, we're going to divide by negative 3, and a negative divided by a negative is a positive. So there's our positive 3 that we needed. Okay? So that's what happens when it's a multiplication problem and you're turning it into, isolating the variable. Okay? Well, what about division then? Okay, so division looks like this. Now, we're no longer going to look at it and see it like that. Okay? They're going to put it as a fraction because when you learn about equations, they try to make as small a space as possible. So they try to utilize their space. So they're going to put it like that, x divided by 4. We did that when we did our expressions. Some of you guys didn't quite do it yet, but we want to put it as a fraction, x divided by 4. Okay? And let's say x divided by 4 equals 5. Okay? Now, what divided by 4 gives me 5? If we can think ahead, we know 20. 20 divided by 4 is 5. So we know our answer should be 20. But how do we get there? Okay? Well, once again, I don't want this to be a 0 because if this becomes 0, you can't divide something by 0. It ends up being undefined. I want this to be a 1. Okay? But really, it kind of gets into our fraction rules, which is really kind of, it takes us back to, having to remember if I multiply the tops by something and then divide and then I get 1. To me, I could go through all that, but I think it's just as confusing. If I keep with my rule of instead of dividing by 4, I'm going to multiply this whole thing by 4. That gets rid of it. To me, that's a simpler way to remember it. Instead of dividing by 4, we're going to multiply by 4. What happens is these cancel out because it's really technically 4 over 1, which gives me 4x over 4. Remember, and I said that's all confusing? But if you just remember that it cancels out, then remember we got to multiply this side by 4. Whatever we do to this side, we got to do to this side. That's what gives us our 20. Okay, let's do another one. X divided by negative 3 gives me a 6. Okay? Well, instead of dividing by negative 3, let's multiply by negative 3 so that they cancel out. But then you got to multiply this by negative 3. Okay? You may want to put that in parentheses so you don't think it's 6 minus 3. But that's going to be negative 18. Okay? If we put that in our original problem, negative 18 divided by negative 3 is a positive 6. Okay? One more. Let's do another negative. Y divided by negative 2 gives me a negative 5. Okay? So instead of dividing by negative 2, we're going to multiply by negative 2. Okay? And negative 5 times negative 2 is a positive 10. 10 divided by negative 2 is a negative 5. Okay? So I would check those. They're going to start out small. I'm going to keep them small for a little bit. But remember, do the opposite. If it's multiplication, do division. If it's division, do multiplication. Okay? All right, I'm going to put some problems up here for your assignment and mix them all together. So I'm going to put some addition and subtraction still in this one from the prior one so you can keep getting practice with that and that you can see them all together, okay? These are still addition and subtraction. Okay, and then now we're going to see some multiplication. Okay. Let's see. y divided by negative 2. And this last one is g divided by negative 4. I thought I'd mix in another letter there. Equals 3. Okay? So you got some addition, subtractions, you got some multiplication, divisions. So it kind of mixes them all together, but there's still just one step. Just do the opposite, isolate that variable, and we'll check these the next day, okay? All right, keep at it, guys.